Sometimes Venn diagram is useful to visualize set relationships. However, it is useful when you have 2 or 3 sets. If you have more than 3 sets, it's more trouble than convenience. I would say it's difficult to consider all the possibilities. For instance, take a look at A is a subset of B. Let's visualize this relation. So this can be one possibility. Here this is inside, this is A, and outside that's B. You can see that A is contained in B, right? Or sometimes they are actually the same thing. A is the same as B, they overlap, they coincide, and in this case A is still a subset of B. So therefore in this case, this simple case, you have 2 possibilities. Now if you look at A is not a subset of B, and what are the possibilities? This can be the first one. Oops. This can be the first one. This is A, this is B. You can see that they are actually one has nothing to do with the other. So A is not a subset of B. Or you can have this guy. So when they're intersecting, so this is A, this is B. Certainly A there are some elements A that's not in B, right? So therefore this could be another possibility. Or sometimes this can be another possibility. So B is inside, A is outside. You can see that there are elements in A but not in B. So you can see that just a simple relation, and you can see different possibilities. However, when you have smaller, just 2 sets, sometimes Venn diagram can be convenient. Now here's some definition on operations on sets. Now let A, B be subsets of universal set U. We say union. So when we union, we act on both. We put them together. That's the union. So this is one of the operations. So if we union them, that means I'm going to draw. This is my A. This is my B. So when we say union, that means we put them together. That's why we union. So everything will be put them together. So the shaded area will represent this result. So now, as a result, so we will say X in A or X in B, right? So if you pick arbitrary elements from A union B, it's either in A or in B or in both at the same time. But that already means it's either in A or in B. So that's how the union, how we define the union. So keep in mind, this is all shaded area, That's the union, okay? And this is the intersection. So when we have 2 sets, we can have one operation intersects them. So the intersection is, if we draw the Venn diagram, so the intersection, the so-called intersection, will be this one. Okay. So therefore, it's X in U. X is elements from the U, so that X in A and at the same time, and this is N, and at the same time X is in B. So therefore, it's the common shaded area. So this will be common shaded area. That's what the intersection is. Now difference of B minus A. So if you have a B here, this is your A. So this is A, this is B. So when you B take away the elements from, take away all the elements in B that belongs to A. So therefore you have to take away, this is B, take away these elements. So you are left with this side, right? That's what it is. So it will be X in U. Now X in B, but X is not in A. And this notation means the complement of A. So if I draw it, this is the box represents the universal set, and this is my A. The complement means anything but not A, so outside of the A. So in other words, X in U. where X is not in A. Now, sometimes here these are just two sets. We have some scenarios of two sets. Sometimes we have a certain number of sets, like from A0 to AN, the union, I from 0 to N, AI. This, we can extend this definition to here. So that means X in U such that X in AI for some I, okay, for some I from 0, 1 to N. So that's one of the that's how we define it. So the union is X has to be in at least one AI, for at least one. Now, of course, when this is 0 to infinity, that there are infinitely many sets, so you just extended X in U, and X is in AI for some I greater than or equal to 0, because there are infinitely many from 0 to infinite, so as long as it's greater than or equal to 0. And similarly, the intersection definition can be extended to X in U, X in AI, X in AI for all I from 0, 1 to N. That means when X is in the intersection of all the AIs, X must be in every single AI. X must be as elements for all the subsets, for all the sets. Now, of course, when this is infinity, then X is in U, X is in AI for all I greater than or equal to 0. Okay. All right. So that's how we define those operations. Now let's actually do some exercise. Okay. After we define those. So let A be X in R. So X is actually X. These are real numbers, and where X is greater than 0 but less than or equal to 2. B is X greater than or equal to 1 but less than 4. Let's find A union B. So sometimes it might be easier for you to draw both sets. So this this is real line, and this is 0, 1. Maybe I'll say 0, 1, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. And the first set is X is greater than 0, less than or equal to 2. So I'm gonna graph that X greater than 0. So 0 is not included, but greater than and less than or equal to 2. So the solid point means includes. The circle, open circle means exclude that point. So you see all the X in between 0 and 2, including 2, that's what I'm shading. So that represents the set A. For set B, X is greater than or equal to 1. So 1 is included. So I'm going to use a different color. So 1 is included, solid points. And then greater than 1, greater than or equal to 1. So to the right of 1. And less than 4. 4 is not included. So now I shaded set B. Let's A union B. If you remember A union B, that means the common, all the shaded area. So if I have you take a look at, if I move this so that they coincide, and then I'll try to figure out what the all shaded area is, right? So you can see that it's actually from 0 to 4, not including the both boundary points. So here you can see that that's a collection of all X, where X is from 0 to 4, excluding the boundaries. So again, I'm looking for all shaded area in this case. So those will be kind of useful tricks. And let's take a look at A union B, the complements of that. You already know that X is in in between 0 and 4. So the complement means as long as not that, right? Outside of this area. So maybe I'll draw another one. So we already see 0, 0 to 4. So and then that's what we shaded, okay? And what's the complement? The complement means just opposite of that. So therefore it's my green shaded area, okay? The green shaded one. That's what it's supposed to be. So therefore it's gonna be x less than or equal to 0, or x is greater than or equal to 4. Now, intersection of A and B, if you remember, intersection means the common shaded area. So if I move those two, I hope that you see the common shaded area is just from 1 to 2, including 1 and including 2, right? So the graph sometimes is useful. So x in R, x is less than or equal to 2, greater than or equal to 1. That's the common shaded area. And then B minus A, so you're going to remove A from the B. Again, the first one is A, the second one is B. If you look at, if removing, the other way around, I'm sorry, removing A from B, okay, removing A from B. So the A is from here to here, you're going to remove that. You're going to remove that piece from the B. So it will be x in R, x greater than 2, less than 4, because all the values 2 and below in here will be removed. So that's what we have. The A complement, which is the complement of this set, and seems to me it will be here to the right, and here will be solid point to the left. So the green representation is for this one. Okay, so in other words, it's gonna be x less than or equal to 0, or x is strictly greater than 2. Okay, now the last one is the complements of A union, intersect the complements of B. Now sometimes it might be useful to draw the complements, and then you find the common shaded area, right? So here earlier we say, hey, this is the complement of A, this is the complement of A, and look at the complements of B will be solid here and go there, and this will be open circle, go to the left. That's the complement of B. And let's try to find the common shaded area. So the common shaded area, I'm trying to find, hey, this is common shaded area, right? These are all shaded at the same time. And here these are all shaded at the same time. So therefore I know that it will be x is less than or equal to 0, or x is greater than or equal to 4.